Hello, I would like to welcome you to the video tutorial regarding overview of functional programming languages. In this video, I wish to discuss and elaborate an introduction to the functional programming language. Why functional programming matters. The concepts behind functional programming language. Relative advantages of functional programming. Relative disadvantages of functional programming. Comparison to imperative programming. First of all, let's look at what is a programming language. According to McLennan's explanations, a programming language is a language that is intended for the expression of computer programs and that is capable of expressing any computer program. And functional programming is a programming paradigm, a way of constructing the structure and elements of the computer programs that treats computation as the evaluation of mathematical functions and avoids state and mutable data. Functional programming emphasizes functions that produce results that depends only on their inputs and not on the program state. It is a declarative programming paradigm, which means programming is done with expressions. Now, let's find out some characteristics about functional programming languages. It has a simple syntax, has few primitive functions from core of language. It is easy to learn and extend. It has no side effects, which means a pure language. Iteration is done using recursion. And also prefix notation is the basic syntactic structure. It uses automatic storage management, has a basic control structure, high level of abstraction. It is well suited for parallel machines. These programs are very easy to check for validity. Also avoids the complexity of temporal reasoning. Most of the time interpreted rather than compiled. Bit slower when compared with procedural languages. Next, I would like to draw your attention why we should really go for functional programming. As we know, day by day, programs become more and more complex. It is more and more important to structure it well. Well-structured software is easy to write, easy to debug, and provides a collection of modules that can be reused to reduce future programming costs. Conventional languages place conceptual limits on the way problems can be modularized. Functional languages push those limits back. In this video, we show that two features of functional languages in particular, high order functions and lazy evaluation, can contribute greatly to modularity. As examples, we manipulate lists and trees, program several numerical algorithms and implement the alpha beta heuristic. In other words, an algorithm from artificial intelligence used in game playing programs. Since modularity is the key to successful programming, functional languages are vital important to the real world. Functional languages are, in my opinion, good for mainly two things: gaming AIs and mathematical computations. It is good in gaming AIs because of its nice limits manipulations and mostly in Lisp and Scheme, and for mathematical computations because of its syntax. Both Scheme, Lisp, and Haskell have a syntax that makes mathematical computations easy to read. It is worthwhile learning about the concepts that are behind. A number of concepts and paradigms are specific to functional programming and greatly foreign to imperative programming, including object-oriented programming. However, programming languages are often hybrids of several programming paradigms. So programmers using mostly imperative languages may have utilized some of these concepts. High-order functions are functions that can either take other functions as arguments or return them as results. In calculus, an example of high-order function is the differential operator, which returns the derivative of a function. Higher-order functions are closely related to first-class functions in that higher-order functions and first-class functions both allow functions as arguments and results of other functions. The distinction between the two is subtle. Higher-order functions describes a mathematical concept of functions that operate on other functions, while first class is computer science term that describes programming language entries that have no recursion on their use. Higher order functions enable partial application and currying, a technique in which function is applied to its arguments one at a time, with each application returning a new function that accepts the next argument. This allows one to syntactically express, for example, the successor function as the addition operator partially applied to the natural number 1. Another one is polymorphism, where it is enforced by the compiler or not, is a core value of functional programmers. Confusingly, C++ programmers call this concept generic programming. I will compile some practical advantages of functional programming now. Most functions language provides a nice protected environment, somewhat like Java language. It is good to be able to catch exceptions instead of having code dump in stability critical applications. Functional programming encourages safe ways of programming. I've never seen an off by one-off mistake in functional program. Functional programs tend to be much teasier than their imperative language counterparts. Often this leads to enhanced programmer productivity. Functional programming encourages quick prototyping. As such, I think it is the best software designed for paradigm for extreme programmers. Functional programming is modular in dimension of functionality, where object-oriented programming is modular in the dimension of different components. Generic routine with easy syntax. Many housekeeping tasks made for you. Deconstructing data structure, pattern matching, storing variable blinds, lexical scope with closures, storing type, type interface, garbage collection, storage allocation, whether to use pointer to value or value directly, safe multithreading. Immutable data structure are not subject to data race conditions and consequently don't have to be protected by locks. If you have always allocating new objects rather than destructively manipulating existing ones, the locking can be hidden in the allocation and garbage collection system. On the other hand, there are some relative disadvantages of functional programming. Most people find functional programming to be difficult to understand. This means it will probably be harder for you to write functional code, and it will almost certainly be harder for someone else to pick up. Functional programming languages are usually slower than a language like C would be. This is becoming less of an issue over time because computers are getting faster and compilers are getting smarter. Not being as widespread as their imperative counterparts, it can be difficult to find libraries and examples for common programming problems. For example, it is almost always easy to find something for Python than is for Haskell. There's a lack of tools, particularly for debugging. It is definitely not as easy as opening up Visual Studio for C++ or C Sharp or Eclipse for Java. Finally, I will give a comparison to imperative programming. The functional programming paradigm was explicitly created to support a pure functional approach to problem solving. Functional programming is a form of declarative programming. In contrast, most mainstream languages, including object-oriented programming languages such as C Sharp, Visual Basic, C++, and Java, were designed to preliminary support imperative or procedural programming. With an imperative approach, a developer writes code that describes in exciting detail the steps that the computer must take to accomplish the goal. This is sometimes referred to as algorithmic programming. In contrast, a functional programming approach involves composing the problem as a set of functions to be executed. You define carefully the input to each function and what each function returns. The table describes some of the general differences between these two approaches. Although most languages were designed to support a specific programming paradigm, many general languages are flexible enough to support multiple paradigms. For example, most languages that contain function pointers can be used to credibly support functional programming. Furthermore, in C# 3.0 and Visual Basic 9.0, explicit language extensions have been added to support functional programming, including lambda expressions and type interface. And that concludes the session. Thank you for watching.